another thing we can say regarding these elementary matrices and their inverses is that E1 inverse, E2 inverse, E3 inverse multiplied by E3, E2, E1 turns out to be equal to the identity. Why? Well, if we multiply E1 inverse by, E3 inverse by E3, we get the identity. And the identity in the middle of this string of matrices can just be eliminated because the identity multiplied by either the matrix before or the matrix after it gives you just the matrix before or the matrix after, depending which you multiply. So the identity essentially just disappears. And then that brings E2 inverse and E2 into juxtaposition. They're consecutive, so that these would be multiplied, which would give us the identity. And E1 inverse times the identity times E1 is just E1 inverse times what we get if we multiply the identity by E1. And that's just E1, so we get E1 inverse times E1. And E1 inverse times E1 is the identity. And what does that tell us? Well, that tells us, remember that E2, E1, E3, E2, E1 is just A inverse. So that this product of the inverse matrices is A inverse inverse, which equals A. So if you multiplied, now we got to be careful to do this. We start with E3 inverse. We take E3 inverse and we multiply it on the left by E2 inverse, and then multiply that on the left by E1 inverse. We should get our matrix A. Okay, now we'll go ahead, just having had this little digression, which is relevant to understanding how these matrices and inverses work. We'll go ahead and do the LU decomposition.